So this is kind of the last module of this set for the first day. It really is just an overview of how you would build up the whole project to give you the ability to do your error detection and manage the other programs. So it just takes you through a kind of a sequence like this. And we do a template actually. There is a template that exists that works in a similar way to this, which they use at a lot of places. Just basically they take the template and put it on the machine and then write the programs around the template, and it seems to work fairly well. But if you think about a program structure for a machine, you basically have a starting condition where your machine's not enabled, i.e. you turn it on, you don't want it to leap into action, you want it to be there, powered up, but not running. And then when someone inputs something or presses a button or throws a switch, you want to be able to go to the active state, and then you want to do various functions, and if an error happens you want to be able to process the error. So you can see the boxes there give you that kind of idea. So we power up, we're in disable state, someone puts an on switch somewhere and it goes to the active state. From the active state someone presses a button, or a button on an HMI or something that says, right, we're going to datum the machine, do the homing, or we're going to run the motion. We need to go back from when we finish that into the active state, and then from any of those, if you turn the switch back to off again, you need to go back to the disabled state, and obviously if there's some kind of error we need to go to the error state. Okay, so it's just a state machine, fairly logical I think. Having gone to an error state, everything's gone wrong, there is only really one way out of that, and that's to kind of reset the machine in a way. So from there you go back to the disabled state again. So there's kind of no path back from an error to go back to running again. You've got to go around the whole loop again because everything went wrong in this particular case. And obviously you can depending on the machine, you can change this as required. And each machine tends to have its own requirements really. So the bits of program you've been running, I think you should have already probably written something with run in it. Yeah, there's some programs that run another program. So the program name and the process number is optional. We can stop and we can halt, which stops all the programs, which we've got down there. The stop with the program name, that used to be how it went, but then if you imagine you've got, like we've been doing just now, multiple programs with the same name, you need to be able to do a stop with the program name and tell it what process number it's on. So that's why there's an optional process number on the stop command.
If you run it without the process number, will it just stop all the versions of it that are running?
No, if you run without the process number, it will basically allocate a process number automatically.
Right.
It will allocate the highest one available. So if you just click run, as you do in Motion Perfect, you'll always find it has the highest number, because that's by default is what they're... Okay, so stopping motion, of course, we've seen already, we need to use the cancel command, not the stop command, because cancel stops the motion. Rapid stop will stop motion on all axes. It doesn't actually provide a faster stop. It just stops all the axes. Okay, so although it's called rapid stop, it doesn't decel any faster. If you do want to stop all the motion on all the buffers, because here, look, you've got two moves in the two different buffers, forward and reverse. If I just do a cancel, the first one will cancel and the reverse will begin. But if I want to clear everything and stop everything completely, I need to put the 2 in brackets on the end. So cancel 2 or rapid stop 2 will basically clear everything out. Okay, we've looked at printing I think already. I've shown you printing to a different channel. So that's just
so one
of that.
question.
Sorry.
When using merge on and increase the buffer limit to 64, is it any function to clear all 64 buffers?
Yes, if you do cancel 2, it will clear all 64 buffers.
Okay.
Yeah, it will work even if you do that. Because internally it kind of treats the 64 move buffer as if it's one move inside the system logically. So if you look at n-type, it's still only one move in there. So anyway, back to our little diagram here. So this just goes through the different bits of stuff. So when we go to the disabled state, we basically you start the machine as if you'd had the machine running. So you stop at any programs that might be running, you stop any motion, and you set the status indications for it being disabled. Even if normally you do this even after power up, so even though you know nothing's running, you would still go through and do this. And the stop command's fine. If you do a stop command in the program, if the program's already stopped, it won't mind. It'll just ignore it. Now there's only one exit from this particular box, and that's back to the active state when we turn on the master switch on there. And there's a little program which is in your sheets which does that. So you can see there you've got it does the stopping, stops all programs running. There's a rapid stop to stop the motion, waits for both axes to stop there with the wait idle, turns off an output. There's a status LED, turns off the watchdog, and then goes into this bit to wait until the input 2 is on. So when you turn input 2 on, that then enables the machine, if you like, to the next level. And when input 2 is on, it runs the startup to set up your axes, and then goes to the active state with the go sub. Okay, so in the active state, we've effectively we've enabled the drives, we want to set the status up, and there's the ability to go to one of two programs now, the datum or motion, out of that, or we can exit back to the exit machine data, exits to machine data. Interesting. Okay. Oh yeah, so that's although it says exits, it means it comes out of that particular box there and heads to those other ones, and then it can go to motion error if there's an error. This obviously needs adjusting for size, this particular slide. We can go back to the disable state with the enable off. So again, it's in this active state. Notice that it now goes around a loop, so it does go a while when loop. So as long as input 2 is on, it will go around that loop continuously scanning. So with the watchdog on, output an LED on to say that it's in the enable state, and then some information appears on an HMI. This is just a local print 5's on there. And then it's got two waits here, one for input 3 to go off, because this is like a start button, so it's looking for a rising edge on 3, if you like, and then wait until it's on again. So when that goes from off to on, it then goes on down to this bit here. But these waits and tills have also got a condition so that if input 2 goes off, it knows it needs to go back to the disabled state, so it's looking for that as well. And if there's a motion error, it knows it's got to go to the error state, so it's looking for that as well. So if it comes out of these two waits, it could be because of three things, one of three things. It could be that it's in error, it could be that we've turned it off and it wants to go disabled again, or it could be that we actually want to start the motion. And this bit here is the one that decides that. So if it was in motion error, it goes off to the motion error routine, or else if the datum's complete and input 2 is on, it goes to the main program. If the data is not complete, it goes off to the datuming program. So it's got like an auto datum in this one. So if when the first time you run it, it will go, oh, I'm not datumed yet. It will go off and do the datum, do all the homing, and then come back. And the next time you run it, it'll say, oh yes, I am homed, so therefore I'll go off and do the actual machine job. Okay, and then we carry on through similar things. So the datuming one, this is effectively the homing, sorry, go back to that. Effectively the homing routine that we've already done, I think. So we can exit to an active state, error state, or actually go off and do, or go back to the disabled state. So we either finish the datuming and go down the black arrow there, or we go off to an error state, or they do turn input 2 off and it goes off that way. And again, a little program, quite a small program this, because the actual homing routine is the program you wrote that's a separate program. So where it actually does the homing is, run dataming, it's the first one, yeah. I was looking too far down. Yeah, so run dataming. So the first thing it does is go off and run the dataming program. So it goes off, does the homing. And this is one where you might use proc to actually as an active thing. So it's running dataming on process 2, and then we wait until process 2 has gone to 0. So the proc status of proc 2 is 0, that tells us it's finished. So we sit there waiting on that line until it's finished. I need to change this slide actually because that is slightly dangerous, that sequence there, because it could be possible you do the run dataming and get to this line so quickly that it hasn't started to run dataming yet. So dataming is already, the status of proc 2 is actually 0 when you get there. That's waiting until it's not 0, so I was waiting until it runs. There is a catch with this. Sometimes it can get caught out, and I prefer now just to put a time wait in instead of doing that, because I've seen that get caught where it either gets stuck there or it comes through without waiting. So yeah, that line there is better as a time wait than doing that complicated extra thing there. Okay, so that's doing the dataming, and then at the end of here, if there's no motion error, if there is a motion error, we go off there, and if there's no motion error, we check into again, and then we go off and return back to where we came from, basically. And then the next bit's the running program, which will do whatever motion it is. We can come out of that back to the active state, or error state, or disabled state. And this bit here is effectively set up. We've changed this now, haven't we? This in your sheets, I don't think you'll find on GoTo. This is a very old command in BASIC. In your sheets, it should say something like select case, or something like that. Because this is like 1960s BASIC, this line here, so I'm trying to avoid it. You can still use it, but it's not what we should have in the training. I need to change the slide. I've changed the sheets. I think pretty sure they don't use on GoTo. But effectively, it's looking at two inputs here, 4 and 5, and using that as a numerical value. So it's either a 0, 2 zeros, or a 1, or a 2, or a 3. So you get 3 numbers out of that. And in this case, with on GoTo, it will go to one of 3 programs, depending on the number you receive from that. On your sheets, it should be, I think, select case, and then it goes to case 1, case 2, case 3.
Yeah, it's a case,
Yeah. So that's a much more modern way of doing it.
Page number 8.
Yeah, it's a more modern way is to use select case, but it's the same effect. You're going to these different programs. So it runs tuning. The other bits here would be populated with other programs, like you've done the other different programs. So you can select which one you're going to go to with that. And again, we're running those on process 2 and then waiting until process 2 is finished before coming out of that to check for the errors. We can reuse process 2, that's fine. You don't have to say every program has its own process number, but you obviously can't run 2 programs on the same process number at the same time. You can run 2 programs on the same process number so long as they're not doing it together. So there's no harm in having the dataming running on 2 and the tuning on 2 and anything else. So clearing the errors. Have you used this one yet, datum 0? I think I showed it first thing this morning and you probably didn't know what I was talking about at all. Datum 0 it's a special case of the datum command. It doesn't actually do any dataming. It doesn't set any position values. All it does is clear the error flags. So if there's any error flags in the axis status, as in for a following error warning or a remote drive error or something like that, it would clear those flags, and then you can reset the axis again and turn on the watchdog again. Other than that, the datum command is what it says. You've used it for homing, but datum 0 is just a special case. There's no homing at all. Do you know the command if you want to 0 an axis, to actually set it to 0? Sidnat does. Anyone else?
No, I think I told you.
Yeah? Remember what it is?
To set what, sorry?
To actually set the axis position to 0, to actually do it.
Diff pause.
Def pause, yeah. So some people think datum 0 looks like it should be setting it to 0, but it's not.
No.
Yeah, but def pause, defined position, is the one that sets it to 0.
Actually, yeah, we can use 0 or any value for def pause.
Yes, exactly.
We can preset.
Yeah.
The axis.
Exactly.
But this, I'm not sure when we use the EtherCAT, is it working or because sometimes maybe we make some
Def pos you mean, or?
yeah def pose with the value.
It should work.
Yeah,
Yeah, it should work.
but I'm not sure I used it or not. But
Yeah. No, it shouldn't care what type of access it is. Def pos will set dpos to whatever value you have it in.
because you know how the EtherCAT actually the EtherCAT make it synchronize between the position counter inside the controller, position counter
Yeah.
inside the drive.
Yeah.
So
But
if
when
you
you
change something here,
when-
you need to synchronize.
Yeah,
with that.
nothing happens to the EtherCAT when you do def pos. It's all inside the controller.
Okay.
It applies an offset. It simply applies an offset
okay,
to the
okay,
position
got it.
sent to the drive.
So it's all inside the controller. It
Yeah,
doesn't,
yeah.
doesn't change anything inside
Yeah.
the drive.
So
I remember when we use a can open, actually when we change something inside the controller, it makes some jump on,
Yeah.
on the model because
Yeah,
the model
yeah.
wants to be synchronized. I mean, it's slave. It
Yeah.
should synchronize with the master. So
Yeah.
when we change
yeah.
position counter.
We went through a lot of that jumping when we were developing EtherCAT, but now it doesn't jump.
Okay,
It's fine.
Yeah, if it's working like offset,
Yeah,
it's okay.
yeah. Okay, so this box is when we go into error. There's only one way out of that, and that's the yellow one going back to a disabled state. So all we've got to do really is tidy things up in the program to deal with a motion error, and maybe flash a lamp to say, hey, we've got an error. So there's a little lamp flashing routine, which is a bit underwhelming, really. So there's your lamp flashing routine. It just goes output 8 on, wait for 200 milliseconds, and it goes around that loop, just flashing the LED. We don't actually have a flash command in BASIC, so you have to do that manually.
We should have.
we should have a flash command. There's a command called timer, which will turn an output on for a time, but then you still have to repeat that in a loop because it won't.
Like toggling,
Hmm?
it's toggled the output.
Timer will turn it. It doesn't
No,
toggle
it's,
it.
It's toggle.
Oh well, we need a toggle, yeah, or something.
Yeah,
Yeah,
something
yeah,
like
yeah.
that. Yeah,
In
the
the
ladder
IS
program.
in the ladder program, yeah, there are lots of blink, as someone
Blinking,
said. Yeah,
toggling.
there's lots of things that you can use.
HMI, they said toggle.
Yeah.
This is the expression.
That's it. So you can see there we print some stuff up, we flash an LED, and then it's pretty simple really. Once the input 2 is turned off, so it waits until that input 2 is turned off, which says the operator has actually acknowledged that there's an error. So he turns input 2 off, and then we clear the motion errors, turn on the servos again, and go back to the disabled state. So notice we don't turn the watchdog on, we turn the servos on, which just means they're ready for servo processing, but we don't turn the watchdog on at this point. So the watchdog is only turned on in the next bit. Well, actually the first bit. So you go back to the active state again, which was right at the beginning, to actually do all the enabling. So that's kind of an overview pictorially of what is kind of written on the sheets of those program sequences.